Alright, this is Ken Roosevelt. We're talking about tree diagram for conditional probability. This is an example from your book. It's example 4-31. It's on page 223. And I'll use this one and then I'll take two from Alex. So this might take two videos. Here we go. Box 1 contains 2 red balls and 1 blue ball. Box 2 contains 3 blue balls and 1 red ball. A coin is tossed. If it falls heads up, box 1 is selected and a ball is drawn. If it falls tails up, or not heads, then box 2 is selected and a ball is drawn from it instead. Find the probability of drawing a red ball. So you can see, since there's an unequal number of balls in the box 1, then there is in box 2, and there's an unequal number of red to blue ratio, that whether you flip heads or tails is going to make a difference in the outcomes. So these are conditional probabilities. These are dependent events. And the first one, first event that happens is the coin flip. So two things can happen on the coin flip. We can get heads or we can get tails. Now I can put tails there, but to harmonize what I'm doing here with what you'll see in Alex, I'm going to put not heads. Not heads is the same as tails, right? So I'm going to put not heads. Okay. After that, we can draw a red ball, or we can draw blue. And instead of putting blue here, I'm going to put not red. So I'm going to go like this. And same thing down here. We can get red or not red. And the end result, let me do this. End result will be a head and a red of this path. This results in a head and a red. This results in a head and a blue. This results in a tails and a red. And this results in a tails and a blue. Okay, so there's 4 possible paths, and each path has its own probability for its final outcome. So let me just get rid of these guys, and I'll start filling in the probabilities with you. So first, what's our probability of getting a heads? Well, it's 50-50 shot, so that's not too hard. So I'm going to put P of heads is a half. P of not heads or tails is also a half. So no problem there. Now what do we call this line? Well, notationally, we're trying to get to red, but where did we come from? Heads. So this is probability of red given heads. And our chance of that is looking at box 1. There's 2 red out of 3 there, so it's 2/3. And this right here is our probability of blue given heads, which is 1/3. Down here we have probability of red given tails, which is 1/4. And down here why'd I put R there? Ooh, let me fix that. That should be a P. Sorry. And this is P of blue given tails, which is 3/4. And now what? To get these conditional probabilities that are resulting, we have to go down each path and multiply. There's a formula in your book that says P of A intersect B is equal to P of A times P of B given A. And actually it doesn't matter the order. You could have P of A intersect B is equal to P of B times P of A intersect B. It just depends on which comes first. Does B come first or does A come first? It doesn't matter. But you can see the formula. We're going to multiply this guy here times this guy here to get the probability of both happening. So, pretty straightforward. So how do I do it? Let's use my red pen. So we're looking at P of heads and red. Well, that's equal to P of heads times P of red given heads. So it's going to be 1/2 times 2/3, which is 2/6 or 1/3. I'll put 2/6 because I'm going to add later and show you something. Now this one, this is, if we go along this path, we get a heads and then a blue. So this is probability of heads and blue, which is not red, right? So that's 1/2 times 1/3, which is 1/6. Okay. Next one. Let's go back to the red because this is another outcome that would be red. Probability of tails and red is going to be 1/2 times 1/4, which equals 1/8. And then the last one here. To find the probability of tails and blue, we do 1/2 times 3/4. Basically just taking the probabilities along the path that begins here and continues to this outcome. Okay? And the answer there is 3/8. So